They discard 3 times the iron. They burn what could end famine. They classify survival as waste. Sweet potato leaves contain more protein per acre than the tuber, more iron than spinach, more vitamin A than carrots. Yet across every continent where sweet potatoes grow, the leaves are cut, piled and fed to livestock. The part of the plant that prevents blindness, anemia and starvation is reclassified as agricultural residue. This is not neglect. This is systematic removal of the most nutrient-dense biomass from human consumption, enforced through agronomic policy, commodity pricing, and nutritional databases that until the year 2000 contained no entry for sweet potato leaves. The tuber feeds. The leaves sustain. One is a product, the other is erased. Sweet potato cultivation began in Papua New Guinea approximately 50,000 years ago, making it one of humanity's oldest domesticated crops. Archaeological evidence from the Cook Swamp shows deliberate planting, irrigation channels, and mound systems designed to maximize both tuber and leaf production. The leaves were not a byproduct, they were the primary harvest. Tubers stored energy for lean seasons. Leaves provided continuous nutrition. Austronesian peoples carried sweet potato across the Pacific between 3000 BCE and 1000 CE, establishing it in Polynesia, Melanesia, and Micronesia. In every culture that adopted it, the leaves were consumed daily. Cooked in coconut milk, steamed with fish, wrapped around meat, fermented into pastes. The Maori of New Zealand cultivated kumara specifically for its leaves during the growing season, reserving tubers for winter storage. In the Andes, pre-Columbian societies grew sweet potato at altitudes where other crops failed, consuming leaves as a green vegetable and tubers as a staple. Spanish chronicles from the 1500s describe indigenous Andean populations eating the greens of the camote more frequently than the root itself. The leaves were not secondary, they were the crop. The tuber was insurance. Sweet potato leaves require no replanting. Cut the vine and it regrows within 2 weeks. A single plant produces harvestable leaves every 14 days for up to 8 months. 1 acre of sweet potato vines yields 22 tons of edible leaves annually, compared to 8 tons of tubers. The leaves contain 30% protein by dry weight, higher than soybeans. They grow in depleted soils where grains fail. They tolerate drought, flood, and poor drainage. They need no fertilizer, no pesticides, no mechanization. Harvest is continuous. Storage is unnecessary. The plant regenerates faster than it can be consumed. In tropical climates, sweet potato leaves produce year-round. In temperate zones, they produce from spring to first frost. The vines root at every node, creating a self-propagating ground cover that prevents erosion and suppresses weeds. Traditional Pacific Island agriculture used sweet potato as a living mulch, planting taro and yams within the vine network. The leaves fed the family, the tubers fed the pigs, the vines fed the soil. It was a closed system. It required no external inputs. It could not be monetized. During the Japanese occupation of the Philippines from 1942 to 1945, rice production collapsed. Supply lines were severed. Imports ceased. The Japanese military requisitioned grain stores for their troops. The civilian population was left with sweet potatoes, but the occupying forces and the collaborationist agricultural bureaus issued directives that only tubers were to be consumed by humans. Leaves were classified as animal feed. Hospitals documented widespread malnutrition, particularly vitamin A deficiency, leading to night blindness and xerophthalmia, a condition that causes permanent blindness. The irony was absolute. Sweet potato leaves contain 16,000 IU of vitamin A per 100 grams, more than any other leafy green. The solution grew on every farm, in every backyard, along every roadside, but it had been administratively reclassified. Families were starving for micronutrients while discarding the most nutrient-dense part of the plant. Post-war nutritional surveys revealed that rural communities who ignored the directives and continued eating the leaves had significantly lower rates of blindness and anemia. Urban populations who complied suffered generational health consequences. The famine was not a lack of food. It was enforcement of a classification system that defined edible versus waste. Sweet potato leaves require 200 liters of water per kilogram of edible biomass. Spinach requires 300 liters. Lettuce requires 240 liters. Kale requires 280 liters. Sweet potato leaves grow in marginal soils, with a pH range of 4.5 to 7.5, thriving in conditions that kill most vegetables. They fix nitrogen through symbiotic relationships with soil bacteria, improving fertility, rather than depleting it. 1 hectare of sweet potato vines sequesters 12 tons of carbon annually, more than equivalent areas of wheat or rice. The leaves are harvested without killing the plant, making sweet potato a perennial vegetable in tropical climates. In terms of land use efficiency, sweet potato leaves produce 6 times more protein per acre than beef, 4 times more iron than spinach, and 3 times more calcium than milk. They require no refrigeration, no processing, no packaging. They can be eaten raw, steamed, sautéed, or dried, yet they appear in no international food aid programs. They are absent from FAO nutritional intervention strategies. They are not included in agricultural development projects. The World Food Programme distributes rice, wheat, and corn. It does not distribute sweet potato cuttings. The reason is not nutritional, it is structural. In 2004, a study published in the Journal of Agricultural and Food Chemistry confirmed that sweet potato leaves contain 15 polyphenolic compounds with antioxidant activity exceeding blueberries. A 2007 study in the Asia-Pacific Journal of Clinical Nutrition found that daily consumption of sweet potato leaves reduced anemia in pregnant women more effectively than iron supplements. In 2012, researchers at Louisiana State University demonstrated that sweet potato leaves lower blood glucose levels and improve insulin sensitivity in diabetic patients. In 2015, a comparative nutrition study in Taiwan showed that sweet potato leaves contain more lutein than any other vegetable, protecting against macular degeneration. In 2018, the USDA finally added sweet potato leaves to its nutritional database, 118 years after the database was created. The entry confirmed what traditional societies had known for 50,000 years. The leaves are a complete food. They contain all 9 essential amino acids. They provide more iron than red meat. They deliver more calcium than dairy. They are one of the only plant sources of vitamin B12 analogues. Modern science did not discover these properties. It validated suppressed knowledge. The global sweet potato industry is valued at $16 billion annually. It is based entirely on tuber production. Agronomic research focuses on increasing tuber size, tuber yield, tuber storage, and tuber processing. Breeding programs select for traits that maximize underground biomass. Leaves are treated as vegetative waste. In commercial sweet potato farming, leaves are mowed and composted or fed to livestock. The economic model defines the tuber as the product and the leaves as a byproduct. This classification is embedded in commodity pricing. Sweet potato tubers are traded on international markets. Sweet potato leaves are not. They have no commodity code. They cannot be exported. They cannot be subsidized. They exist outside the economic system that determines what is food. Agricultural extension programs in Africa, Asia, and Latin America teach farmers to grow sweet potatoes for tuber yield. They do not teach leaf harvest techniques. Nutritional education programs promote sweet potatoes as a source of carbohydrates and beta-carotene from the tuber. They do not mention the leaves. International seed banks store sweet potato tuber genetics. They do not preserve leaf-optimized varieties. The result is a global agricultural system that grows 100 million tons of sweet potato tubers annually while discarding 300 million tons of edible leaves. The waste is not accidental, it is definitional. Cassava leaves contain more protein than the root, but are consumed only in Central Africa. Radish leaves contain more vitamin C than the root, but are discarded in industrial agriculture. Beet greens contain more iron than the beet, but are sold separately at higher prices if sold at all. Turnip greens were a staple food in medieval Europe, eaten more often than the turnip itself, until industrial agriculture reclassified them as animal fodder. Carrot tops contain more calcium than the carrot, but are removed before sale and composted. Pumpkin leaves are eaten across Southeast Asia and Africa, but are unavailable in Western markets. Moringa leaves contain more protein than eggs, more iron than spinach, and more calcium than milk. Yet moringa is classified as a supplement, not a vegetable. The pattern is consistent. The underground or fruit portion is commodified. The leaves are erased. The economic system requires a single harvestable product. Continuous harvest systems cannot be mechanized. Perennial vegetables cannot be patented. Leaves that regrow cannot be controlled. The food system is not designed to feed populations. It is designed to move commodities. Global food systems are approaching structural failure. Aquifer depletion is accelerating in every major agricultural region. Topsoil erosion is removing arable land faster than it can regenerate. Synthetic fertilizer production is dependent on natural gas, which is subject to geopolitical disruption. Monoculture grain systems are vulnerable to single pathogen collapse. Climate instability is increasing the frequency of simultaneous harvest failures across multiple continents. In this environment, the plants that survive are the ones that were never industrialized. Sweet potato leaves grow in flooded fields where rice drowns. They grow in drought conditions where wheat fails. They grow in depleted soils where corn cannot germinate. They require no supply chain. They need no processing infrastructure. They are a closed-loop food system. When centralized agriculture collapses, decentralized systems persist. When supply chains break, perennial crops sustain. When fertilizer becomes unavailable, nitrogen-fixing plants continue. The crops that were erased are the crops that endure. They were not removed because they failed. They were removed because they succeeded without dependency. If this vault revealed what they discarded, subscribe to preserve what the system erased. Knowledge survives only when it is remembered. The next vault opens soon.